Hello everyone, my name is Pat and I would like to welcome you to this instructional video on the setting up and shutting down procedures for the typical Oxy-Fuel gas cutting station. Today at the end of this video lesson, you'll be able to identify the major components of the Oxy-Fuel gas cutting system, as well as perform the correct assembling and dismantling procedures for the system components. For the purpose of this video lesson, I'm going to assume or suggest that everyone has watched my short PowerPoint presentation listing and describing the components of the Oxy-Fuel gas cutting station in greater detail. The watching of this material prior to this instructional video will give you a broader understanding of the terminology and components that we will be referring to today. This presentation can be viewed at the website mybrainshark.com and can be found under the name 3240 Media Enhanced Learning Oxy-Fuel gas equipment. The use of the Oxy-Fuel gas cutting equipment is common throughout many industries. Its applications include the cutting of steel plate, pipe, and structural shapes, as well as washing, gouging, and heating applications. The use of the Oxy-Fuel gas cutting equipment is safe, providing you learn and follow the safety rules. But remember, the potential for serious injury or harm to yourself and others is very real and should not be taken lightly. It is important that you learn and follow the safety rules. The main components of the Oxy-Fuel gas cutting outfit include two gases, one of oxygen, the other of fuel gas, such as acetylene or propane. The cylinders which house the gases and the valves atop of each cylinder. The cylinder pressure regulators. The oxygen and fuel gas hoses, the torch assembly and its components. The first thing we want to do is make sure that our bottles are in the upright position and securely fashioned as not to fall or tip over. This is important because oxygen is stored at high pressure inside the cylinder, and any damage to the cylinder or the cylinder valve has the potential to cause serious damage or injury. As well, when working with the fuel gas acetylene, it too needs to be used in the upright position. This is because you do not want the liquid acetone, which stabilizes the acetylene inside the cylinder, to drain into your regulator, hoses, and cutting fluid. Next, we will unscrew the protective caps and crack the cylinder valves. Cracking of the cylinder valves is simply opening the valve, turning the valve counterclockwise very briefly to allow a small blast of gas to escape from the cylinder, removing or cleaning any dust or dirt from the valve seat that may get clogged in the regulator or the hoses. Remember when cracking the valves that you stand off to one side and do not open the valve in the direction of others. This stream of pressurized gas can harm or injure those in its pathway. Next, we are going to attach the pressure regulators to the cylinder valves. Gases are stored inside cylinders at higher pressures than needed to perform cutting or welding tasks. Regulators are installed to control the flow of gas from the cylinder so that lower working pressures may be maintained. Most regulators have two gauges. The one with the higher number indicates the cylinder pressure, or how much gas is in the tank, and the other gauge indicates the working pressure. This is the reduced pressure that you are using to perform your tasks. Your fuel gas regulator will be the one that has the lower calibration range on the gauges. Fuel gas regulators can also be identified by their left-hand threads and a small groove or knurl in the fitting. After hand tightening the regulator to the valve, we will snug it with a crescent wrench. No need to over tighten, just snug it up. Oxygen regulators have higher calibration numbers than fuel gas regulators and have connections that are right-hand threads. Once again, after hand tightening to the valve, just snug up with a crescent wrench, but no need to over-tighten. At this point, I'd like to mention a safety device called a flashback arrestor. These devices are designed to stop the progress of a flame from burning back into the hoses or regulators by shutting off the gas supply when receiving backwards pressure. They also act as one-way check valves, keeping gases separate, reducing the risk of fires and explosions. WorkSafe BC regulations state that flashback arrestors must be installed on all Oxy-Fuel cutting systems between the torch and the regulator. Make sure that you have a flashback arrestor installed on your equipment. My flashback arrestors are here at the regulators. And once again, in the torch, many torches today have flashback arrestors built into them. Next, we're going to attach the hoses to carry the gases from the regulators to the torch. These hoses consist of 2 or 3 layers of rubber and a layer of fabric reinforcement. The red hose is used to carry the fuel gas, and the green hose is used to carry the oxygen. The fuel gas connection has left-hand threads and attach in a counterclockwise direction. The fuel gas hose connection has the same grooved or knurled notch in the fitting as in the fuel gas regulator. The oxygen hose connection has right-hand threads and connects to the regulator in a clockwise direction. A safety point to remember is that before using burning hose, it is a good idea to inspect the hose and repair any damaged sections with a proper repair kit. You should never use tape to repair hoses. And once again, we'll snug the connection with our wrench, but do not over-tighten. We are now going to attach the cutting torch to the hoses. Once again, the fuel gas connection has left-hand or counterclockwise threads. The oxygen fitting has right-hand or clockwise threads. Snug the connection with a wrench, but again, do not over-tighten or force the connections. We need to make sure that the pressure regulator adjusting screw located in the center of the regulators have been backed off so there will be no pressure exerted on the working pressure gauge when we open the cylinder valves. Turn these adjusting screws counterclockwise until they turn freely. Now, slowly open the fuel gas cylinder by turning the valve counterclockwise. The fuel gas cylinder should never be opened more than 1.5 turns. This allows for quick closure during an emergency. At this point, you can check the cylinder pressure gauge. This is the gauge closest to the cylinder connection. You want to make sure that the cylinder is not empty, and if it is empty, you need to change it. Next, we will open the oxygen cylinder fully, turning the valve handle several rotations. Once again, after opening, check the regulator gauge closest to the cylinder to make sure the cylinder is not empty. Many equipment manufacturers will suggest pressure settings and cutting tip sizes based upon the thickness of material to be cut. These charts list the correct oxygen and fuel gas pressures to be set on the regulators. As a general rule of thumb, between 5 pounds to 8 pounds of acetylene pressure and 30 to 40 pounds of oxygen pressure are very common, and a tip size of 0 or number 1 is appropriate for many cutting thicknesses. We will now adjust the fuel gas working pressure. To set the fuel gas working pressure, we will first open the fuel gas inlet control valve on the cutting torch. This is the one with the red hose attached to it. We will turn the inlet control valve counterclockwise to open about a half turn. We will turn the pressure adjusting screw in the center of the fuel gas regulator clockwise, increasing the pressure and reading on the working pressure gauge until it reads between 5 to 8 pounds of pressure. When complete, close the gas inlet valve on the torch. We will now repeat the process for setting the oxygen pressure. Open the oxygen inlet control valve on the torch 1/2 turn. This is the one with the green hose attached to it. Turn the adjusting screw in the center of the regulator clockwise until the working pressure gauge furthest from the cylinder indicates 35 to 40 pounds of pressure. Once set, close the inlet control valve on the torch body. Our next step is to check for leaks. There are various methods to do this. The most common method is to spray all the connections with a soap and water solution. Any leaks should be apparent by the large soapy bubbles that form at the connection sites. When working in confined spaces, it is also common to immerse the entire section of hose along with the torch in a barrel of water. And if any leaks should develop, the bubbles will rise to the surface of the water. If you find any leaks, retighten the connection and retest. No leaks. So when there are no leaks, it's time to light your torch. Before lighting your torch, we should use the proper personal protective equipment and be aware of our surroundings. Our basic PPE should include cotton or wool blend clothing, coveralls that will not burn and better protect you from the molten metal, leather gloves with steel-toed boots, a leather cap for head protection is recommended, and of course eye protection. Colored cutting goggles or a cutting shield should be worn to prevent eye damage from the cutting process. Also check your area for flammable materials. Make sure you know where the nearest fire extinguisher is or water line. Be aware of the sparks from your cutting torch can travel a considerable distance. Before lighting the torch, you must first purge the lines. This means briefly opening and closing each of the torch's inlet control valves separately. This assures that only the intended gas is flowing from the designated line and reduces the risk of a mixed gas explosion. To light the torch, we will open the fuel gas inlet valve on the torch body a half a turn, allowing for the flow of fuel gas. Next, we'll use our striker, not a match or a lighter, to ignite the gas. Then we'll increase the amount of gas by further opening the inlet control valve until the heavy black smoke disappears. At this point, you will begin to add oxygen to the flame by opening the other inlet control valve on the torch. The flame characteristics will begin to change from a yellow-orange flame to a blue flame, possessing rounded white inner cones. At this point, we have produced what is called a neutral flame. Now you will depress the oxygen cutting control lever on the torch and readjust the oxygen level if necessary to fine-tune and maintain the neutral flame. Your cutting torch is now ready for use. To shut down, turn off the fuel valve and turn off the oxygen valve. After closing the fuel gas inlet control valve and closing the oxygen inlet control valve to extinguish the flame, we will close the fuel gas cylinder valve and close the oxygen cylinder valve. Next, we will bleed the lines. This means opening the fuel gas inlet valve once again to release the remaining gas trapped inside the line. You should see the readings on the regulators has returned to a reading of 0. Then we will back off the pressure adjusting screw on the regulator to the loose state. Lastly, close the fuel gas inlet valve. Repeat the process for the oxygen line. At this point, you can put away or store the equipment for future use or dismantle the components using the reverse order of the assembly, which would be disconnect the torch from the hoses, disconnect the hoses from the regulator, disconnect the regulator from the valve, put the caps back on, and put the bottles away. In summary, I'd like to say that if you learn and follow the correct procedures and use your personal protective equipment, the Oxy-Fuel gas cutting procedure is safe, useful, and a beneficial skill to have when working in many industries. Used improperly, it can cause extreme damage to property and possessions, though most importantly, remember that improper use can result in permanent and serious injury to yourself or others. I want to thank you for viewing this video and hope to see you again. Next time we will take a closer look at the Oxy-Fuel gas cutting techniques. Bye for now.